Oh, hey, we have something cool to show you today. Some company called Zelensky Labs or something was having a going out of business sale, and we thought this lasery thing would be pretty cool for the show. Is it plugged in?
Powering up.
This is gonna be cool. You made sure it wasn't turned on, right?
Popcorn's ready. Dr. Hanson?
I think I've been shrunk. Or is it shrank? This is not good. Let's figure this out like a scientist. Think, observe. Actually, it's really hard to see. Everything is so dark, which makes sense. My irises are super tiny, not letting in a lot of light, but who needs to see, right? Hey, what just happened? What? Hold on. They can't hear me. I can't seem to hear them either. I can explain this. A full-sized ear responds to frequencies between 20 hertz and 20 kilohertz because of how the hair cells in our cochlea vibrate. Full-size human voices fall between 85 and 255 hertz, but my inner ear is so small I can't hear anything less than maybe 400 or 500 hertz. And even if my tiny lungs could move enough air for an audible sound wave, my itty-bitty vocal cords are probably ringing at 20 kilohertz or higher. If only there was a dog around. I'm cold. Really cold. Well, I'm about 100 times shorter, which means I've got about 10,000 times less surface area and 1,000,000 times less volume to make body heat. I'm gonna have to eat like a hummingbird down here just to keep from freezing to death. I wonder where that popcorn went. Come to think of it, I don't know why I'm still conscious. The hemoglobin in my blood is probably smaller than the oxygen molecules it needs to carry to keep me alive. I'm sure there's a perfectly good And that Zelensky machine should be illegal. Actually, I'm pretty sure I just broke several laws of physics. Shrinking someone shouldn't be possible. If that beam were capable of destroying atomic matter, it would have looked more like this. But what if it removed the empty space in my atoms? The nucleus holds more than 99% of an atom's mass, but it's 100,000 times smaller than an atom is wide. In other words, if an atom was the size of the Big Apple, the nucleus would be just an apple. Problem is, this isn't how atoms really work. Electrons aren't exactly anywhere. At any moment, we can't predict for certain where one will be orbiting. If we go looking for it, quantum mechanics says there's a high probability the electron will be orbiting here compared to, say, here. But there's some chance it could be anywhere. Imagine a spinning fan. We know there are 4 blades in there, but we can't say exactly where they are. But if you put your hand inside, you're definitely going to find one. Now, electron's orbit is a cloud of places it could be, and an atom's empty space isn't really empty the way we normally think of it. This is the weirdness of quantum probability. We also can't shrink me just by pushing my atoms closer together. That would violate the Pauli exclusion principle. Our cloud view of electrons only tells us where we'll probably find them. But if we push 2 atoms closer together without bonding them, the higher the probability that 2 of their electrons would be found in the same quantum state. And in this universe, that's just not allowed. We could add energy and move electrons to higher cloud orbitals all on their own, but that would take pressures approaching the inside of a planet or a star. Not particularly good for your health. Atoms are the size they are because of the rules of the universe. And since we're made of atoms, that goes for us too. But that doesn't explain what happened earlier. For now, let's just keep today's experiment between us, okay? Stay curious. Look out the window of your pressurized house into the deadly vacuum of space, and this is the last thing you want to see. But that's exactly what astronaut Tim Peake saw earlier this year, a chip in the window of the International Space Station. Thanks science for quadruple layered space glass. Whatever made that mark was only half the width of a human hair.
It was an attack from near-Earth orbital cosmic debris.
Also known as space junk.